I'm free, free falling.
Next unit, we're looking at what's called constantly accelerated motion. So what's kind of weird is, for the next week and a half, we're only going to study one special case of motion. And that's when something constantly accelerates. So that means you're at a stoplight and you're not moving. Is that constant acceleration? No. How do you accelerate in a car? What do you got to do? You step on your gas pedal, exactly. And when you constantly accelerate, you keep your foot on the gas pedal the whole time. Now in real life, a car doesn't accelerate at a constant rate because you have gears and things like that. So that's kind of weird. Like we're spending like a week and a half studying something constantly accelerating. That like never happens in real life. That's just kind of like bizarre, right? So like when do things like constantly accelerate? That like never happens, right? Yeah, I should throw the stapler. That'd be kind of bad, right? Exactly. Yeah, usually I run around, I knock stuff off people's desks, but that's just kind of annoying. So free fall is a great example. That when something is under only the influence of gravity, you have constant acceleration because gravity doesn't kind of pull on you and then stop pulling. That's just weird. Gravity pulls on your body all the time. The other thing that's kind of weird is, even though it's like 21st century here, we don't actually know how gravity works. We're still trying to figure that out. And you know that guy with the really bad hair? E equals mc squared. We're talking about Mr. Albert Einstein. Einstein, up until his deathbed, was trying to figure out how does gravity actually work? How does every mass, every particle mass in the universe exert a force on another particle proportional to the total mass there? And no one can figure it out. It's just weird. But we can describe gravity really well. And the guy we got to give credit to first was this guy, Galileo. And this is actually what he looks like. We got a photo of him. No, it's just an actor. Here's the basic idea. Galileo was able to figure out how constant acceleration worked by using one of these things. It's just a wooden ramp. And here was his genius. If you think about it, if you drop something, does it fall fast or like fast? What do you think? Yeah, it's actually really fast. We kind of take it for granted. But the acceleration due to gravity is a crazy number. We're going to look at it's 9.8 meters per second every second. That means nothing to you. It's 32 feet per second squared. That also means nothing to you. So here's something that means something to you there. How do you know how fast acceleration is in a car? You look at the 0 to what? The 0 to 60 test, right? And remember we looked at Mr. Lau's old college car, my 1995 Ford Escort, woo, 88 horsepower, 0 to 60 in 13.8 seconds. Is that a good acceleration or bad acceleration? Yeah, it's pretty lame, right? That's about a little bit more than a school bus if I floor it. But I have a little trick. If I actually drive off a cliff, there you go, I can actually out-accelerate pretty much any stock sports car you can buy off the lot there. I can go 0 to 60 in like 2.7 seconds is a good way to look at it. About 22 miles per hour per second. So gravitational acceleration, you're like in the ultimate hot rod. You live in an ocean of gravity, but you just take it for granted. So here's what Galileo figured out. If you drop something, it's very hard to measure. So what he came up with was using an inclined plane, a wooden ramp here. And let me zoom in. So this is Galileo in his workshop. This is actually him now, just an actor with a wig on and like a big old beard. But what he did is, if you actually go to the University of Padua, I think it's right outside Pisa, Italy there, you can visit his workshop and you can actually see, when you take a tour, these wooden ramps that he used and his telescopes. And what he did is he rolled little tiny balls down the ramp. And what he figured out is what makes the balls speed up down the ramp? Gravity, exactly. So the hard thing is how do you measure that ball rolling down the ramp? So you could use some kind of meter stick ruler, which he could have. But the hard thing back then is there's not a good way to measure what? Not a good way to measure time. So you could try using your pulse, but if you get excited, your pulse might be off, right? You could try using like a water clock dripping, but you know, if somebody gets confused and not sure where the bathroom is or it evaporates, who knows, right? Eee. So what he came up with was brilliant. He put these little tiny bells along the ramp, and as the ball would roll, it would hit one of the bells, and kind of like a ball falling under the influence of gravity, it would hit a bell, and then it would hit another bell, etc. And all he had to do was adjust the spacing of the bells so that the time was equal, so then they could figure out how far it goes in equal intervals of time. So what if Galileo heard ding, ding, da ding, ding? What's the problem? Two of the bells are too what? Close. What if he hears ding, 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 ding? What's the problem? Two of the bells are what? Too far. And here's what's cool. Once he got the bells equally spaced, he measured the distances. And what was freaky is he always got this pattern, no matter the ramp that he tried. It was always this pattern, which we're going to see in a second. And at first he's like, oh, what happened? Like, why do I get this evil like pattern? Did I sell my soul to the devil? 666, red devils. And when he realizes it's actually the fingerprint of nature, he called it the natural distances. So you know what? His contemporary Leonardo da Vinci was really close, but Leo was off. Galileo nailed it. If a ball accelerates 1 unit of distance the first time interval and the second interval, if you're skiing, whatever, right? Are you going to go 1 unit of distance or more than 1 unit as you ski down a hill or go snowboarding? You're going to go what? More than 1 because you're what? Starts with an A. You are accelerating. Turns out you actually go 3 times the distance. So guess what the next interval of distance would be? It would be 1, 3, what's the pattern? It's going to be 5, then 7, then 9. Or if you look at it in terms of a free fall motion, Leonardo thought this. Leonardo thought 1, 2, 3, but what was actually correct is you get these odd integer patterns. Or if you add them up, you actually get the natural squares. We'll see that in a second.